Welcome to Developer Roadmaps. In this explainer, we're going to map out a really crucial part of JavaScript: how it thinks, how its logic flows, how it makes decisions, and just as important, what it does when things, inevitably go wrong. So here's our game plan for today. We'll kick things off with the whole idea of control flow. Then we'll check out the tools JavaScript gives us for making decisions. After that, we'll cover how to handle failures gracefully. And finally, we'll wrap up with some best practices for writing code that's truly resilient. When you get right down to it, every useful program is just a series of decisions. And that's what we call control flow. It's like the logic engine inside your code, the part that decides what happens next and why. So, last time we talked about loops, how to make JavaScript do things over and over. Now we're shifting gears from the question of how many times to the much more interesting question of which way to go. It's really the next logical step in making our code intelligent.
By default, JavaScript just reads your code like a book. Top to bottom, one line after the other. But that's not very powerful, is it? Control flow structures are the commands we use to break out of that. They let us tell the program to jump, to branch, or to make a choice based on whatever's happening at that moment.
Okay, so what's in our toolkit for guiding this flow? Let's break down the essential statements that JavaScript provides to create these decision points, these crossroads in our code.
First up is the absolute cornerstone, the OG of control flow, the if statement. It's basically a simple gatekeeper. It asks a question, and if the condition in the parentheses is true, or something truthy like a non-empty string or any number that isn't zero, then, and only then, does the code inside its block get to run.
And of course, we can chain these decisions together for more complex situations. Looking at this code, we first check if the score is greater than 90. If it is, boom, the grade is A and we're done. If it's not, we move on to the else if and check if the score is greater than 80. And if all the other checks fail, that final else block is our safety net, a catch-all for every other possibility.
Now, the crucial thing to get here is the order. JavaScript checks these conditions one by one, right from the top. The very first one that turns out to be true gets to run its code, and the entire rest of the chain is just skipped. Only one path can ever be taken.
Now, what if you have one single variable that you need to check against a whole list of specific values? You could use a long chain of if-else statements, but that can get pretty messy. That's where the switch statement comes in. It can be a much cleaner, much more readable alternative.
And this slide just shows the difference perfectly. On the left, you've got this repetitive series of if statements. It works, but it's a bit clunky. On the right, the switch statement just makes the intention crystal clear. We're taking the day variable and choosing a path by matching it against each case.
Okay, see that break keyword? That little word is everything. It tells JavaScript, hey, we found our match, get out of this switch block now. If you forget it, the code will actually fall through and execute the code in the next case too, whether it matches or not. It's a super common source of bugs, so you've got to watch out for it. All right, now for something a bit more compact, a bit of a pro move, the ternary operator. It's basically a tiny if-else statement that fits on a single line. It's perfect for when you just need to assign one of two possible values to a variable based on a simple condition.
Let's break this down real quick. The condition, score greater than or equal to 50, that's the question. The question mark is like the word then. If the condition is true, the result variable gets the first value, pass. The colon acts as the else. So if the condition is false, result gets the second value, fail. It's incredibly efficient for these simple assignments.
So far, we've been talking about the happy path, how to direct our code when everything is going right. But what happens when that path just crumbles? Now we're going to pivot to error handling, planning for failure, so our applications can recover without just crashing.
Because no matter how perfectly you write your code, things will go wrong. I guarantee it. You'll get some unexpected input, a network connection will drop, a server will hiccup, the script will break. So what do you do then?
When that happens, it's called a runtime error or an exception. It's an error that happens while the program is already running. And without any kind of safety net, it just stops everything, dead. To your user, this feels like a crash, an abrupt, broken experience.
So, to prevent that from happening, we use the try, catch, finally structure. Honestly, the best way to think about it is as a safety net for your code. We try to run some risky code, and if something goes wrong, the catch block is there to grab the error without letting the whole program fall apart. And the flow is super logical. The code in the try block runs first. If everything goes smoothly, the catch block is just skipped entirely. But if an error does happen, execution immediately jumps to catch. Now, here's the crucial part. The finally block runs at the very end, no matter what. Error or no error, it always executes. This example shows it perfectly in action. In the try block, we're attempting some operation that might fail. If it does, control jumps to the catch block, where we can maybe log the error so we can debug it later, and then, no matter what happens, that finally block runs. It's the perfect place for cleanup tasks, like closing a file or a database connection.
But what if the code isn't technically broken, but something is logically wrong for our specific application? Like, say, a user submits a form with incomplete data. Well, we can actually create our own errors using the throw statement. This lets us intentionally trigger our own catch blocks to handle these kinds of application-level problems.
It also really helps to recognize JavaScript's built-in error types. You'll see these all the time. A type error means you tried to do something with the wrong kind of data, like trying to call a number like it's a function. A reference error is the classic, oops, I tried to use a variable that doesn't exist yet. Recognizing these patterns is going to make you so much faster at debugging.
So, we have the tools, now let's put it all together and talk about the core principles of writing professional, stable code that can handle pretty much anything you throw at it. Okay, here are the key takeaways. First, use try-catch for genuine, unexpected emergencies, not as a weird replacement for a simple if-else check. Second, if you catch an error but don't know how to handle it right there, it's best to log it or even rethrow it so something higher up can deal with it. Third, please, for the sake of your future self, write clear, helpful error messages. And finally, reserve that finally block for essential cleanup you need to guarantee happens every single time. And there you have it. You can now build code that makes intelligent decisions and can recover gracefully from failure. Next time, we're going to dive one level deeper into the very core of that logic, the operators and expressions that power every single comparison and calculation. Thanks for watching this explainer from Developer Roadmaps. Map your path, build your career.